So let's talk about this one, 123, how you import libraries. Now I said every program tries to load at 400,000 in memory, but all modern programs are portable executables, and they're compiled with a relocation section. So they can relocate in memory. And that's because of address-based layout randomization. The operating system will load them somewhere random, not at 400,000. That's the model. Now that's good for security, but to analyze files, you often want to stop that behavior and load it right where it belongs. For example, the thing we did a couple projects back where we manually decompressed a packed file, that putty dump thing works best when it's really at 400,000. When it's somewhere else, you often have trouble dumping it. So it would be nice to actually stop this relocation behavior to make the file easier to analyze. So here, you get a simple program that just prints hello, and then you can go here and look at the import address table and see all the API calls it's going to make. And this particular program, everything it's going to use comes just from kernel 32. Use all these API calls, but they're all in the Microsoft library, kernel 32. All right, and so here's various sections showing how it's going to find things, which I'm not going to worry about too much. You can see how it loads them in the file in memory. If you use HXD, you can see in memory how it matches the information you see on the disk file. So you'll see this description, DAD905, and here it is, DAD905. Like I say, all the loading a program into memory is just taking whole sections and just putting them the way they are into memory, if you don't have a compressed file. So, all right, and here's another demonstration just so you can see it, and this shows how you calculate what address it's going to go to. The relative virtual address is where it's going to go in RAM. And the image base address is almost always 400,000, but it often is relocatable in memory. And if you look in OllyDebug and run it, you'll see here, if you actually run this program, it doesn't load at 400,000. It loads at a random address. Like here it is at 1C0,000. That's address-based layout randomization in action. And we want to turn that off to make it easier to analyze files. So you download this program. Didier Stevens wrote this. All it does is change a flag in the header to say this program is not relocatable. So if you get this program and then just run it, you can do -D to remove the dynamic base flag. So it makes it an older program that can't relocate, and now when you run it, it will really load at 400,000. And this is usually what you want for analysis. Stop moving it to a random place, put it in this one place where I can find it and work on it, and the addresses I see in OllyDebug will be more easy to understand. And some of the tools will work better. So I thought I'd mention that one, and there are a couple of programs you play with to fix here. And like I say, you can save yourself a lot of bother by modifying these files so they stop relocating before you analyze them. And that's a small address. And so again, there's various programs you're going to fix here that are broken in various ways. Some of them you just examine the program and find memory bytes, and then you're going to have programs that are broken. One of these you're going to find, this one here, I gave you some source code because one of the DILs is missing, or the name is hidden, and you're going to have to Google to find out which DIL offers these functions, WSA cleanup and stuff, and put it back. So there's programs to fix there, and I'll help people that get stuck in the interactive part. Often students come to me for help with these projects, especially the harder parts. But you get to practice analyzing files at the binary level and fixing them at the binary level. All right, that's what I wanted to show you. Let me stop this one.